Hello everyone, welcome back to part 2. We're going to be taking a look at these problems. Remember, our focus is to always follow good problem solving steps, which is outlined in here, and that's what I will be reiterating as I solve these. Alright, so our first thing is to find the equation. So this is looking for the amount of energy. So I'm looking for Q. You're going to write down that formula, so hopefully we're matching. And then immediately, because I had asked you to work on these, right? Immediately I'm going to write down those variables. And I always like, again, to write down what my initial and what my final temperature was to get those correct. So I'm looking for a mass, and I see 50.0 grams. The specific heat capacity is 4.184 joules per gram degree Celsius. And here is my temperature final minus temperature initial. So it's 80 degrees Celsius minus 20 degrees Celsius is equal 60 degrees Celsius. That was simple math. Going to insert them with the units on it. So I have 50 grams. I have my specific heat capacity. Remember, I'm just following these letters. And the change of temperature is 60 degrees Celsius. Once I cancel everything out, I should have an energy unit that's left over. So grams cancel out, Celsius cancels out. My J's are not very good, are they? And then the unit that's not canceled out is the unit my answer is in. So when I do the math, I get 12,552 joules. All right. It does it, and then always reread. It just says the amount of energy. It didn't ask it for anything else, but a lot of times they do ask for things to be in kilojoules. So just again to practice, I'm going to move the decimal place 3 places over to 12.552 kilojoules. But for this problem, that's all that the answer asked for it to be. All right, we're going to go down here. And really, I start just kind of looking over the problem, trying to find out what are they looking for. All right, it says calculate the amount of energy. So again, this one is the Q equals M times S times change of T. I'm going to list these off to the side. And my mass, I look at as 1.92 kilograms. My specific heat capacity is 0.89 joules per gram degree Celsius. And my temperature, I didn't do that, did I? I have an initial and I have a final temperature. So my final is 155 degrees Celsius. My initial is 73 degrees Celsius. And when I minus that, I get 82 degrees Celsius. So as I'm looking at this, one of the things I have to say, is it in the required units? And I notice kilograms for mass is not. It should be in grams. So I'm going to change that to grams. If I would not have caught that and put all those original values in here, when it came time to cross things out like we did here, we would catch ourselves that, hey, I have a kilogram and a gram and they're not canceling out. So again, that would be where you would catch that. So mass is 1,920 grams. Specific heat capacity is 0.89 joules per gram degree Celsius. And change of temperature is 82 degrees Celsius. I'm going to cancel out Celsius and grams. Yay, my joules looks really good. And then Q is equal to 14,000, oh no it's not, sorry, 140,121.6 joules. So you can see that's a pretty big number, and they get pretty big fast. Again, I'm going to reread the problem. It says, what is the answer in kilojoules? So it wanted the amount of energy, and then now it wants me to put it into kilojoules. Now technically, right, I'm going to move this 3 places over, 140.1216 kilojoules. But again, I'm fine if you just write 140.12 kilojoules. If you want to shorten it up a bit, they're both good. All right, I'm just looking at my answer that I had prepared for it, and I did not do my joules to kilojoules correctly. Somehow I have 1.4 kilojoules, but that's not right. We need to move it over 3 places. Let me just check the math real quick, make sure that this number, original number, is not wrong. So 1920 times 0.89 times 82. Nope, that is a big number. So this is the answer in kilojoules. See, even I can make a mistake on my pre-made answer key. All right, so let's take a look at these on this page. I did write down the answers for you, but we're going to solve them together. So hopefully, if you did not solve these on your own, please stop this video and you work out all of these. And even if you don't match the answers, keep going down, and that way you can compare what happened. Was it a math error? Did you not realize there was a unit that needed to be changed? What was it? So stop the video now and do the setups and all of the math. Thank you. All right, so this is calculate the amount of energy. So again, that's a Q that it's looking for. Notice I didn't even read the entire problem. So I'm listing my variables over here, right? You're checking your answers against mine. I'm looking for a mass, which I see as 136.3 grams. Look at that. I'm just kind of just going through the problem here. And I have specific heat capacity 0.385 joules per gram degrees Celsius. Again, write all those units on it. So it said it cools it from, and this is my initial, and that is my final temperature. So I'm going to write down what it looks like. Here is my final minus my initial. And I get a negative 132 degrees Celsius. It's a negative because negative says that, well, the temperature decreased from 155 to 23. It gave off energy. That's what a negative value means. It gave off. Instead of absorbing, and then increasing its temperature, it actually got cooler. Sort of, this happens too, like when a brick house heats up all day and then you go by it at night, you can just feel all that heat being released. That would be also a negative energy, meaning it's being released. Excuse me. So Q is equal to 136.3 grams. Specific heat capacity is 0.385 joules per gram degrees Celsius. And I'm going to make sure I bold negative 132 degrees Celsius. I always bold my negatives so they stand out to me because I've lost points in my life. So everything cancels out. It leaves me with joules. But it's going to give me a negative 6926.8 joules. It's not a wrong answer to have that negative value because, as I said, it's cooling. All right, so this answer is the same answer as the exponent that they gave to us, the scientific notation. So remember, in scientific notation world, when it's a positive exponent, it means it's a large number. So if I was to put this to an ordinary number, I'm going to move it 3 places, and it looks like this. And negative 6,930. Now, they didn't carry a whole lot back there because they have rounded it when they wrote this, but these are close enough that they're the same answer. So recognize if it's written in scientific notation, and if you get an ordinary number in your calculator, that those are the same answers. Okay? Now, again, I should write joules on that because everything needs to have a unit. So in this particular one, scientific notation is how it was expressed. You don't have to do that. You can leave it as an ordinary number, but know that they mean the same. All right, so let's take a look at this next one. It says, and I'm just like kind of perusing, what is the specific heat capacity, right? Because my first quest is to get those formulas. That's what I see. What is the specific heat capacity? I really do, I don't read too in depth when I'm doing a problem because I'm so focused on trying to get that equation. All right, so I'm going to list these variables, Q, M, change of T. All right, so it says 288.0 joules. It says the mass of 10 grams of metal. And here again, I'm going to write down it went from 25 up to 60. So you can see that it increased in temperature where this one decreased. So the final minus the initial. So what's my final? What is that? 60 degrees minus 25 degrees Celsius. And I get 35 degrees Celsius as being the temperature change. So I'm going to write this in here. I'm going to write what my Q is, 288.0 joules. It'd be just fine if you wrote 288. And then I'm going to do my mass as 10 grams. And then my temperature is 35 degrees Celsius. Now, when I write this like this, nothing is canceling out. And it really shouldn't, because we learned that the specific heat capacity units could be joules over gram degrees Celsius or calories over gram degrees Celsius. So none of these are going to cancel out, and you can see that I have the units for specific heat capacity. So the specific heat capacity is 0.823 joules per gram degrees Celsius. Is that the answer? Yes. Again, if you gave me just 1 or 2 decimal places, all is well. All right, one more to go, and I hope that you got this answer. Let's take a look if you did not. All right, so it says how many calories of energy. So it's looking for energy. Again, I'm going to write down my equation, and I'm going to list over here the variables that I need to pull out. So I'm looking for a mass. So this is 0.513 grams. My specific heat capacity, there it is 0.13 joules per gram degree Celsius. And it went from, this is the initial, to the final temperature. So final is 39.5 degrees Celsius minus 30.0 degrees Celsius. So I think that's a pretty easy one to calculate without a calculator. Notice that no matter what problem we're doing, whether it's density, specific heat capacity, or any other problems that come your way, I do it the same way all the time. I don't decide, oh, this time I'm not going to list the variables, or this time I'm not going to write the equation. Problem solving is doing the same thing over and over and over, so it becomes a habit to write the equation, a habit to list the variables, a habit to write units on everything. Do it the same way all the time. It's when students start mixing things up that you start missing either checkpoints or missing the details. Okay? So Q is equal to mass 0.15, am I saying that right? 0.513 grams. The specific heat capacity is 0.13 joules per gram degree Celsius. And my change of temperature is 9.5, and that is a degree Celsius over there. Again, same thing. Cancel, cancel, so that you see that you have your energy unit, and I get 0.634 joules. And then maybe you wondered, why didn't your answer match that? Because if I read it, it says it wants it in calories. So that is a dimensional analysis that we learned on the first page on how to take joules from calories. Yes, and you're going to need those conversion factors in order to do it. All right? It isn't anything that's in the top of your head. Remember, those conversion factors would be on a sheet. Okay? So I'm going to take one of those, 0.634 joules times 1 calorie is equal to 4.184 joules. All right? And then I'm going to take and I'm going to cancel those out. So now that I'm in calories, and it's 0.15 calories. And there you go. Hope everyone did well. I hope that you're showing all the proper steps. You know, some students get overwhelmed with specific heat capacity because it's like problem solving. But all I did was the same steps over and over and over again, and found my equation and listed everything, got them to the right unit, reread the problem at the end. It's the same steps over and over. Don't make it any harder than what it is. Follow the good problem solving steps as if it was like a recipe on how to do that. All right, everyone. One of the things you could do to help study for a quiz or an exam is to cover up these answers and work on a piece of paper and make sure that you can do them well. All right, thank you.